right, now first one up, boom, and I'm gonna do 90-second. I'm gonna put that timer on there. The idea behind it, if it's the first time you're joining Raymondson, is that you have a go, you try, because it's by making mistakes, having failures sometimes that you learn. But you have a go at this. You might ace it. I'm interested in this particular case. I'm interested in how you did the question. I'm going to zip it now. I'm going to give you your, well, you got about a minute again, minute 10 you have. And what am I supposed to do? Got to wait on you before I can solve the problem. We'll do some reading. No. Let me see what you got here. I'm looking for there's a book I needed to go through actually. I'll come back to that. That's it. I'm up. You gotta stop. Okay, so I'm gonna press OK there. Press OK. Yeah, right. So, and let's get going. Let's get going. Now, you might have the answer. You might be right. But how you did it is what I'm interested in. And the strategy I want to show you here. Did you try this? Did you try this? Both numbers, we have a multiplication. And we have another multiplication. We need to follow the order of operations. In the UK, we say BIDMAS. In the US, you might say PEMDAS, or you do say, is it PEMDAS? Yeah, PEMDAS. And note the change there, British folks. Note the change here. Division, multiplication. In America, we say multiplication, division. I said we. I'm not American, am I? Multiply, but I sound like it. I know everybody gets caught up with that, you know. Multiplication, division. The order doesn't matter when it's just those two. I'll just throw that out there. Something to explore at a different time. But for this particular question, what's clear is that we need to do the multiplications before the subtraction. The subtraction comes last. That said, I'm going to write a word here, grouping. Grouping. Or actually, if you're in terms of, I would say if I said to factorize, and you'll probably think, hey, it's not algebra. Why am I factorizing? Well, this calculation, in both cases, there's a factor in common. There's a 7. The 7 can come out, and what you have is 7 being multiplied by, and I'm just going to write, I'm putting the multiplication sign. Yeah, I'll put it. I don't need to put it. I shouldn't put it. 7 multiplied by 201, take away 102. You could reframe this problem into multiplication. Yeah, did you do that? Because that makes it a lot easier. Now, when you do 201 take away, and for those familiar with expanding brackets, you'll see if you expand the brackets here, by the way, that you will get the original problem. Check that out. Okay, when you work out what's in the bracket, that's the number 99. So what we have is 7 times 99. And well, hang on. Nobody multiplies by 99. We don't do that. That's actually the same thing as 7 times. I can make it 100 take away 1. Look at me changing and grouping. Because what does that mean? Well, it's actually 7 times 100, 700 take away 7 times 1, take away 7. And that's going to be 693. 693. The most efficient, I would say. You could do in 201 times 7, and maybe you might be quick. You know, 201 times 7, you do that. 102 times 7, you do that. Then you subtract. Nah. And even if you got away with it this time, what if those numbers were much, much bigger? Grouping. Look at what I did there with grouping. That's a strategy you want to start to embed if you haven't embedded it already, okay? Let's move on. Next one, seconds. How many seconds are there in 1,000th of a minute? More seconds, well, less seconds than you're going to get from me, actually. But here you go. Here you go. Let me see what you come up with this one. I'll give you a minute on this one. So I'll stop before. Yeah, I'll stop before the timer comes. Okay, that's a minute there, so we'll stop there. We'll stop there, and let's see what we have. And by the way, remember you have the power of the pause. So if you want a bit more time, just pause the live stream. Pause the live stream now, and you continue working through it. But I'll get going. Okay. How many seconds in in 1 minute? 1 minute is 60 seconds. So 1,000th of a minute is going to be 60 over 1,000. In other words, I'm multiplying 1,000 by 60. That's what 1,000 of a minute is going to be. And now we want to write it as a decimal. What you realize quickly, well, you can divide both by 100. It's actually the same as 6 over 100, which is 0.06. So the answer 0.06. It's 0.06 seconds are in 1,000th of a minute. 0.06 seconds. That's what we're looking for. What can you do in 0.06 seconds? Man, that is fast. Wow, that's a lot of time. Let's go to another one. Let's go to another one, shall we? Here you go. Now we're building ourselves up. You like this? Yeah. Look at the picture. I'll do a minute on this one as well. Or 45 seconds. I'll do 45 seconds. Yeah, I'm gonna do 45 seconds. There, I said it. 45 seconds. You got 45. Yeah. Okay, we're going to stop on this one and let's look at what we have here. Let's look at what we have. It's a 5, it's 5 across, 5 going down, so you have a 5 by 5 grid. Yeah, 5. Yeah, 5, just making sure. That means the denominator is 25. The denominator is 25. 5 times 5 is 25. And then the numerator, how many parts do you have shaded? 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so that's 9 out of 25. Now, percentage, the word percentage means out of 100. Percentage means out of 100, or fraction bar 100. So we want to rewrite this fraction as a fraction out of 100. Fraction bar 100. And that is going to give me, what do I get to 25? I have to multiply by 4 to get 100. Equivalent fractions, whatever you multiply the numerator by, you multiply the denominator. I multiply the denominator first. So multiplying by 4, and 9 4s are 36. So we have 36 out of 100. Out of 100, that's what the percentage sign means. So what we have is 36%. The fraction of the shape that's shaded, 36%. That's what you should have, 36%. Okay, next one is up. Next one is up. Let's move to geometry. Have you ever seen this? Oh. 1 minute again on this because it's if you know your angle facts. I'll give you about a minute. And actually, I would give after 30 seconds. I'll give a hint. Give a hint. Yeah, I like giving hints. And the hint I would give is that, and I'll call that Y. See, in the questions like this, I'll give you 15 seconds, 20 seconds again, but you can't go direct. That's the hint I've given you. Yeah, I've helped there. Okay, we're gonna stop there, and the idea behind this, there's two angle facts you need to be aware of. First, the first angle fact, it has regard to angles about a point. So I have a point. If I do a full turn, I go all, going all around. It's angles about a point. It's 360 degrees. So angles about a point. So making a circle. 360 degrees, they add up to 360 degrees. So if I have 303 degrees, then this angle here is going to be, so my first calculation, 360 take away 303, which gives me 57 degrees. And then, so Y, this angle here is 57 degrees. And at this stage, I said my first calculation, but the truth is, it's my last calculation, because now we just need to work on another angle fact that doesn't require any calculating, and it has to do, these are two parallel lines. Anytime you see this arrowhead going a pair of lines with those arrowheads, it means the lines are parallel. Parallel lines are lines that never meet. They will never cross. They're equidistant all throughout. And for parallel lines, if you get this pattern, this Z pattern, I need a color here, I'll do the red, yeah. If you get a Z pattern with those parallel lines, look at I'm making it Z, 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 Z. If you get that Z pattern, we say they're alternate angles, and alternate angles are equal. So X, alternate angles are equal. Wow, my doctor handwriting. So X is equal to Y, it's equal to 57 degrees. The missing angle, the value of X, is 57 degrees, and it's based on those two angle facts. We use the angle of about a point is 360 to find Y, and then because the lines are parallel and we have the transcendal making that Z shape, that's the name of that line, transcendal. Don't think we don't talk about that in the UK. You'll find it in American textbooks. Yeah, so the line cutting through, or in this case joining the parallel lines, transcendal. I hope I pronounced that right. Disclaimer, if I made a mistake, I'm sorry, but because I don't hardly talk about it, to be honest, these days. But yeah, Z angle, once you see this Z pattern, all to parallel lines, they're alternate angles are equal. Alternate angles are equal. That's the pattern you're looking for there. Next one. Let's go to, oh, this is nice. Now we're into, yeah, this is nice. Won't see one like this in school, would you? But you need to be able to do it. You need to be able to do this kind of stuff, right? Off you go. I'm gonna reset. This is worth two minutes maybe, but I'll give you that. Yeah. Okay, I'm gonna start putting some ideas down. Won't talk, so you still have some more time to do it, and don't peep too much at the screen. But you probably okay. So I'll stop that clock. I'm gonna start to put some ideas. You still have a few moments to work on it, but this one word listing. I'm gonna give every name a letter. And I'm gonna build a list. So, and actually what I need to do, see they said, yeah, I'm talking through, they said that Henry starts. So my strategy, I'm gonna put, well, I gotta put H first. It's H first. And then it's a countdown game. So then Henry, and they're saying that it's a circular order. So I go Henry, then I have to go Iggy, then Joan. So Henry, Iggy, Joan, and after Joan, you're gonna go back to the start to the first name we were given, Fred, because it's all in that's what they're saying, is that seated around a circular table in that order. So this is the order, but we're starting with Henry. So Henry, if you want to see the circle, it's Henry, Iggy, Joan, Fred, Gail, and then Henry. So that's what we're thinking about, but I'm gonna list it out here. So friend, and I'm missing Gail, right? So I got it. We got that there. And then Henry, we're counting down. So Henry does 34. Then it's gonna be 33, 32, 31, 30. And then I'm gonna come back here because I want to see, well, what's the next number that Henry is gonna have. So I'm gonna keep going down. Then I'll list the next 5 numbers, then the next 5, and as I'm doing that, what you're doing is looking for a pattern. Looking at those numbers carefully to see if there's a pattern, because we don't want to keep going all the way down to 1. No, we don't want to do that. If you did that, you worked too hard. Okay, so then I go 29, 28, 27, 26, 25. And I'm looking for 9. Yeah, the ones digit. The ones digit is super important. No, we want a ones digit of a 1. 4, 9, not seeing anything there. 8, 3, 2, 7. You can see there's a difference of 5 every time. Could have done this with maybe a bit of algebra in there because of that. The difference is always the same. I won't overcomplicate it like that. A 6 and a 1. And I'm thinking, my initial thought, I'm not sure, but my initial thinking is it's going to be, oh, why did I choose that color? I'm thinking it's going to be Fred because I saw that 1. But I got to be sure because I have a 6 here. I need to make sure that the pattern is going to repeat. So I continue 25, and then I got 24, and you can see that 24, 23, 22, 21, oh, 21, 20. So 0, 5, 0. What's going to be happening? 0, 5, 0, 5. Do you see where I'm coming from here? And it's the same thing, 3, 8, 3. So when we go, the next numbers are the ones, the teens, yeah. And then, so we're going to have from 19, and we're going to go down. And then we will get to 14, and we'll work our way down. And then we will get to 9 and work our way down. And then we'll have 5, 4, 3, 2. Well, actually, I'm doing it wrong because whoa, it's the 4 here, 4 here. So in the last row, we're gonna have 4, 3, 2, 1. The 1 is in the 4th column if you work through the whole thing, but I'm spotting it, so I'm not gonna work through the whole thing. Fred is going to say 1. It's about making that list, making a list, looking for the pattern. That was the strategy here, and the answer is Fred it is that's the person we're looking for there. Okay, how we're doing now, I have to start looking for time. 21. We got 9 more minutes. What can we find to do in 9 minutes? Let's keep going. Wow, this is simple but beautiful. I'm gonna give you a minute to work on. Actually, I'll do the 90 seconds. 90 seconds is what I'll give you. Now I've got to start. Oh, zip. I've got to start looking at my list. Which one's next? give you a hint on this one. I mean, do not go dividing all these numbers by 45. It's non-calculator. Wow, that's a lot of hard work if you were trying to do that. 45 is 9 times 5. That's the hint I'll give you. 45 is 9 times 5. Think about that. How can you use that to answer this question? Okay, that means I'm up. Unleash the teacher to show you. Because I want to get stuck in. The strategy for this question is not to think about dividing by the 45. It's thinking that any number in the 45 times tables has to be in both the 9 and the 5 times tables, because 45 is 9 times 5. So dividing by 45 is the same thing as dividing by 5 and then dividing by 9, or dividing by 9 and then dividing by 5. Now, once you're aware of that, then you look and you think, well, okay, all these numbers end in 5, so well, I can't use that. All these numbers are divisible by 5. Now we go into this idea of tests for divisibility. All these numbers are divisible by 5, so I can't use the 5, but the 9. I can't tell immediately which of these numbers are divisible by 9, but I can work it out quickly because, and this is the big fact you want to use to get the answer to this, number is divisible by 9. If a number is divisible by 9, sum of digits is a multiple of 9. It's just like 3. If a number is divisible by 3, then when you add the digits in the number, it has to be in the 3 times tables. The same thing for 9. The same thing applies for 9. If a number is divisible by 9, then when you add all the digits, you have to get a number in the 9 times tables. So I'm doing 9 and 4, 13, 13 and 5, 18. 18 is the digit sum, so that's in the 9 times tables. That's not, we're looking for a number that's not a multiple, so this is not what I'm looking for. And then because all the numbers end in 5, and I start seeing something. Hey, 8 and 5 is what? 8 and 5 is 13. 13 and 5 is 18. 7 and 6 is 13 plus 5 is 18. 9 in the 9 times tables. All of these numbers are divisible by 5, and 9 they're divisible by 45. Then 13 again, it's going to be this one because I got my 13 plus 5, which is 18 yet again. So the first 4 numbers are in the 9 times tables and the 5 times tables. I know they're in the 5s because they end in 5. That means they're in the 9 times 5, the 45 times tables. The number that's not has to be E, and I can see it clearly. 6 and 4 is 10 and 5, 15. 15 is not in the not divisible, not in 9s. It's not in the 9 times table, so it's not going to work. So that does not work. That's our solution there. The answer, which one is not in the 45 times table? 645. 645. Okay, off you go. Let me see what you come up with this one. I'll give you you got your minute and a half. I'll give you I'll give you a minute and a half. Well, I'm going to finish with this one. I'll do the solution for this one. We'll go slightly over 30. Yeah, we're going to finish off with this one. But I would guide you through it, or I'll do a bit more help because I'm conscious of the time. If BH is the height of the side AC, then just to make it clear that this symbol, what it means is that that is a right angle. This angle is 90 degrees. Okay. So that's the fact you're working with there. That angle is 90 degrees. Okay. Use that to help you. Another key fact there. I'm gonna tell you, you're gonna have. In the interest of time, I am gonna go through this one, but I don't want to spoil your fun. So if it is something you're making, I've given you 2 facts there that you need to build a question. If you think you're making headway, use the power of the pause. Please, please. Bye bye for now. You know, next week the timetable is gonna change, and I'll let you know how. But I'll post messages so you'll know how it goes. Don't use the power of the pause and finish it, then look at the solution. By the time you finish, I might be gone, but look at the solution. I'm gonna start doing it now. So if you're not sure and you weren't making headway, watch what we're gonna do here. The thing in this is to look at, you need to think about 2 triangles. That's my strategy for this. Now I say my strategy because there could be a different way to do it. I haven't thought of it, so I'm running with the strategy that's come up with me first. It's important that I say that, I think. And that's why we call it creative problem solving. So the first thing I'm thinking about is I'm looking at this from the perspective of 2 triangles. The first triangle is, I'm looking for a color here. The first triangle is this one here, the right angle triangle, the right angle triangle, triangle. So I'm thinking about triangle A. You use the letters to name the triangle. So triangle, you can use this. That's an angle symbol. What am I doing there? So triangle AHB. That's the first one I'm thinking about. Triangle AHB. And from that triangle, what I'm going to note is this symbol, this Greek symbol, is called alpha. Alpha. So what I'm going to note from that one is that, remember, the sum of the triangles add up to 90 degrees. So this angle here is 90 degrees. And what it means is that the angle, this angle, which by the way is the angle we're interested in, CAB. So CAB, CAB. So 2 alpha plus this angle here. And that makes it clear to me what I need to find first. Oh, whoa, what's happening there? What's happening? Oh my goodness. My goodness, what's going on there? I'm going to use that angle. So 2 alpha plus, and I'm going to call that angle A, B, C. No, I'll call it ABC. Angle A, B, C is equal to 90 degrees. So that's the first formula, or the first equation I'm going to write. Yeah, I got to do this with equations. Do I have enough space there? Let me, so let's just recap. What have I done there? This angle is 90 degrees. I'm thinking about the right angle triangle, the one in blue, and 2 alpha, the angle up here, which is the one we want to find, plus the 90 degrees, plus the angle, and it's not BAC. I made a mistake there. I got to go ABC. It's ABH. That's what I want. I named it wrong. ABH plus the angle ABH has to give me 90 degrees. Why do these two have to add up to 90 degrees? Because I already have 90, and 90 plus 90 plus this one and this one gives me 90. 90 plus 90 is 180. So this angle, 2 alpha, plus this angle here, angle ABH, has to give me 90 degrees. So that's the thing I'm thinking about. Now I realize, well, hang on, that means I need to find angle ABH. So how do I do that? To find angle ABH, I start looking at the smaller triangle, the triangle ADB. That's what I'm looking at now, triangle ADB. So I'm going to think about triangle ADB. Have I done that right? No, it's not ADB. Whoa, this is tricky. What a tricky question. What I need to do is create a new point there, and I'm going to call that M. I'm going to call that M. So I'm going to call it AMB. So going from A to M to B back to A, that's a triangle. Triangle AMB. And for triangle AMB, because all the angles have to add up to 180 degrees. All of them have to add up to 180 degrees. So I have alpha plus 4 alpha, and alpha plus 4 alpha, that's 5 alpha, plus the angle I'm interested in, that's the angle ABH. I could call it ABM as well, and that probably will be, because if I stop at M or an H, it does not change the size of the angle. So I can call it ABM. It's the same thing as ABH. Okay. And for clarity, I think I'll make my work a bit pretty. And this is how I hope you see what's happening here. You start building your ideas, and as you build, you refine. That's really important. The idea that you just do a polish, this is the solution, doesn't happen that way when you're thinking through a problem. A, B, I wanted M. ABM is what I'm going to call it. So ABM is what we're going to use. We made this new point ABM. So 5 alpha, look at what I'm saying there, alpha plus the 4 alphas, 5 alphas plus ABM have to be equal to 180 degrees. That's what it is. So now, what can I do? I can rewrite, I'll call this equation 2. I'll call this equation 2, I'll call this equation 1. And equation 2, I can now rewrite it to say that angle ABM is 180 degrees, take away 5 alpha. Angle ABM, this angle here, is going to be 180, take away these two angles. So 180 take away 5 alpha. Hope you're with me. And I hope you can see how we've upped the game. But this is what we're talking about. This is what the kind of stuff we want to get to be able to solve if we're not there already. Okay, and trust me, it does go further than this even for year 7 and year 8. But we can go there. We can scale things. Okay, right. So now let's finish this thing. I need more space, don't I? Space is always a premium. So let's move up. Right, we're looking good there. Yeah, we're looking good. Okay, right. So to finish the job now, we have angle ABM is 180, take away 5x. I can now take that 185x and put it in the first equation. So I'm going to substitute it into the first equation. So I would say substituting in 1, I have 2 alpha plus, and it was plus angle ABM. I didn't change, why did I leave that at H? I was supposed to change it to M, wasn't I? ABM plus angle ABM, and angle ABM is 180 take away 5 alpha. When I add those two angles, I'm supposed to get 90 degrees. That's what we worked out. So it's combining. What we're doing here to solve this problem is we've looked at the missing angles from the perspective of the big right angle triangle, and then we've looked at the missing angles from the perspective of the smaller triangle AMB. With that equation, we can find alpha. We can find alpha now, because what do we have? We're going to do this idea of change side, change sign. So that minus 5 alpha, I'm going to put it on the right hand side to make it positive, and then the 2 alpha I'm going to put on the right to make it negative. So I got 5 alpha take away 2 alpha, and then on the left hand side I'm going to leave the 180. It's going to stay there, but the 90 that's currently on the right, that has to go over to the left. It's positive on the right, so it's going to become minus on the left, minus 90. So we got 180 take away 90 is 5 alpha take away 2 alpha. And on the basis of that, let's continue. 5 alpha take away 2 alpha is 3 alpha. And 180 take away 90 is 90. So 3 alpha has to be 90. And if 3 times alpha is 90, I can write alpha is equal to 30 degrees. Alpha is 30 degrees. We've worked that out. Now we can finish the job, because the angle we want, angle CAB, that's what we're asked to find. How big is angle CAB? And angle CAB, that's the angle at the top here at A. It's actually 2 alpha. The size of angle CAB is 2 alpha. We know that 1 alpha is 30, so 2 alpha. Our job is done. We worked out that alpha is 30. So for the answer to the question, I'm just looking for space to finish this off. 2 alpha CAB, I'm just going to write angle CAB, yeah, is equal to 2 alpha, and that is equal to 60 degrees, because 1 alpha we worked out was 30. So 60 degrees is the answer. I hope that made sense. It's power video, so yes, you've seen it now, but you can watch this another time. And more important than, I also hope that it was fun. I enjoy, you can tell I love solving problems. And the better you get at solving problems, the more opportunities you're going to have out there in this world. Boom. This is a big one for today. Boom. I've given myself 10 minutes. I'm looking at my clock. 10 minutes. Which means the reality, what I need you to use the power of the pause. Please use the power of the pause to spend some time on this. So I suppose it's time for us to say our bye-byes. I'm going to say bye-bye now because I'm going to go through it. And if it is that you pause, then look to the solution. Whoa, robot almost fell there. We're going to end up, say hello. You want to say hello? Okay. Hello. We do lots of robotic stuff. That takes up a lot of my time, but I love it. That linking mats into controlling machines. But let's get back to the focus. Right. You need to be indefatigable to see how you can go through this. I want you to spend some time on it and then look at the solution. So I'm going to start going through it and talking through it now, but you don't want to, you want a chance to read it, think about it, work through it. So use the power of the pause to have your moment and then see what I did and see how it links. And as you go through and you continue, if you, as soon as you get an aha moment from something I'm doing, take advantage of that. That's the power of modern technology. It's not like a fixed live class where I have to rush and you miss your moment. You have even though it's live, you have control over me. Wow, isn't that cool? 21st century. Right. So read, quiet reading. Part of a wall is decorated with a row of 4 squares. So a picture, you want to put in a picture. You want to visualize this idea that you have 4 squares, and I'll just put that there, and I'm not going to get squares, am I? Damn. But yeah, not drawn to scale. 4 squares, okay? So that's the wall there. So you got row of 4. That's your 4 square tiles. And then the other big idea, 3 different colors. 3 different colors. At least 2 tiles of each color. And then this idea, the other bit, that tiles of all 3 colors must be used. All 3 colors. And we want to know how many ways. So that's the question we're asking. How many ways can the row of 4 be chosen? How many ways can the row of 4 be chosen? Okay, how many ways? Now, the question, so the thing that you need to visualize and just build up this idea. I have 3 different colors. So I think the first thing to make this a bit more practical is let's just choose the colors we're going to work with, okay? So we're going to say that, and I'll work with the pens. We're going to say that we have, I'll go with red first. I like red. We're going to say we have a red color. We're going to say we have blue, red, green. Okay, we'll go with green. Yeah, we're going to go with green, red, green, and then the other option is black. So red, green, and black. Those are our 3 colors. The other bit we need to think about is, well, they said, so we have 3 different colors. We're going to make a row of 4 with those colors. We have at least 2 tiles of each color. So the other bit I'm thinking about is I have at least red, red, or green, green. I can think about, or black, black. And does the or? Do I really need that for the model? No. But so they said at least there are at least 2 tiles of each color available. So you know what? I'm actually I should take that out, and I'm just gonna think about that. Do I have more than could I have, for example, 3 or 4 red? Can I have 3 green? This is possible because they said at least. We don't know how much of each color we have, but we have at least 2 of each. But it doesn't actually matter. Why? Because of the next line. The next line says tiles of all 3 colors must be used. tiles of all 3 colors have to be used. That means that I must have 3 different colors. So if the first is red, then the next one could be green, and the next one could be black. But that means that I can only use 1 color twice. Okay? I can only use 1 color twice. In this case, I'm using the red twice. And because you can only use, because all 3 colors must be used, you have to use, everyone has to be used at least once. And then that means that you're going to use 3 colors in 3 slots, and then you're going to have an extra in 3 tiles, and then you're going to have an extra one where you can choose the color. So on that basis, it doesn't matter actually how many more than 2 you have. You're either going to have, you're only interested in using 2 red, 2 green, or 2 black. And that leads me to my first idea of how many ways. To answer these questions, you need to think about how many choices you have. How many choices do you need to make? And for each choice, how many options do you have? So in a choice, how many options do you have? That's what you're thinking about. And the idea of ways, the number of ways you can do it in total is this. This is the model. It's called the product rule of counting. We call this what I'm going to show you, the product rule of counting. And the thing I have to ask you with that product rule of counting, what does the word product mean? When I say that word product, what does product mean? And product means is the answer you get when you do which operation. How do I get so what's the product of 2 and 3? What's the product of 2 and 3? 6. The product of 2 and 3 is 6. The product is the answer you get when you're multiplying. Okay, so what do we have here? The product rule of counting works like this. I'm gonna take off that. I think we have the model spaces starting to become a premium. So I'm gonna put in a box the big idea we're working with. This product rule of counting. How does it work? No, I don't have space there. Space. Right. I'm gonna have to start moving things now and maybe drawing things again. But hopefully we're in there. We have the idea. Okay. Right. The idea we want. The idea of the product rule of counting is, and when you want to know how many ways, what do you need to do? It's for choice 1, you put the number of options. For choice 2, choice 3, and so on and so forth if you have a choice 4. And then options, the options, number of options. I should put number of options, and I need to make that look a bit clearer. Number of options, number of options, and I'm going to put that, so NO, number of options, and the idea is all the options you have for choice 1 multiply by the the number of options you have for choice 2, multiply by the number of options for choice 3, multiply by the number of options for choice 4. That will give you the number of ways you can get a particular combination. You can, in this case, the number of ways you can arrange the tiles in these 4 squares. That's the idea. That's the model you want to use. Number of options. So to answer this question, we need to think how many choices we need to make, and for each choice, how many options we have. How many choices we have to make, and for each choice, how many options do we have? If you get that, and then you multiply those options, you're going to get the answer. How many choices you have to make, how many options in each choice. And so let's build on that model. And what I want to do, I'll put back the square, the picture of the 4 squares, my attempt. That looks a bit better. And what do you think? What's the first choice? What's the first choice you need to make? First thing you need to decide, yeah? You're thinking what I'm thinking? The first thing you need to decide is which color, or the first thing you probably should decide. This you gotta go. Which color you're going to use twice. Remember what we talked about. You have to use each color once. That's going to fill three squares, but then you'll have to use another color again to get a fourth square. So which color, the first choice is which color twice. Which color twice. That's the first choice you need to make. Which color twice. And in this particular case, the color I'm going to use twice. Actually, what am I saying? And now we need to think, well, the number of options. How many options do I have for color to use twice? It could be in my example, I know it's 3 different colors. It doesn't matter what the colors are, but I'm using to make my interpretation, your interpretation more concrete. I've chosen 3 colors: red, green, and black. So red, green, black. There's 3. In terms of choosing which color, there are 3 options. You have 3 options for which color you're going to use twice. After that, after you know which color you're going to use twice, the next option you need to be thinking about is, and let's put a concrete example of what I was going to go with red. Let's use a concrete example to work out what else our situation is. Let's go with, let's say we have red, so that's where we're going, the option we're going with twice. We're using red, and then I have green, and I have black. So that's the 4 the situation we can use. Of course, the other way it can be, and what we're saying is that you shouldn't be choosing from black. I said blue, but it should be black. In other words, the other way you could have been doing it, when we talk about the 3 options, is the other palette of colors you can be choosing from is green, red, and black. And then the final way you can be doing it is if you have, did I do that right? Yeah. If you have the black twice, black, and then the red, green. Yeah, red, green. Note, what I'm simply doing here is saying that palette of choices, it's either going to be this combination we're going to be moving around, this one, or the other one. Those are the 3 choices of having the color twice: red, green, black. Okay. Now the next thing, let's say I'm going to say I'm only going to focus. I'm going to choose this for first choice. Let's say we went with the first choice: red, green, black. Then on the basis of the red, green, black situation, okay, you have to ask yourself, well, where am I going to put them? And perhaps a best way of modeling that is, let's say you pick up the black tile first. So the first single color, how many different places can you put it? So you have a tile that you're only going to use once. You have a color tile, the color you're only going to use once. How many different places, how many different options do you have in terms of where to put it? Okay, so your second choice is first color. Your third choice, the second color. Okay, and by that, what I'm saying is your second, and we're thinking about the singles. Okay, so what do I have? I have do I have a space? Do I have space? Is what I'm thinking about there. Okay, right. And that black, if I'm putting the black in first, there's 4 different places it can go. It can go in the first, second, third, or fourth slot. So 4 options. 4 options. Let's say I've put the black in here. Remember, we're focused on using this particular option. This is what we're focused on, using this option, okay? We're not thinking about the others. We're going with red. We want to see how many ways we can do this, using red, green, black, how many different ways I can organize that. Let's say one way is the black. It had 4 choices. I put the black. Now, because the black is in position, for the next color, how many choices do I have? How many choices do I have for the next color? And the answer to that would be 3. There's 3 choices for the next color. Now, finally, what we have to be thinking about is, so let's say I've put in the green. Whoa, it would be nice if it was actually green. I've put in the green. And then finally, what choices? what can I do with the red? Remember, and this is an important idea because you only have one more color. How many different ways can I put that color in with what's left? I have two. In other words, you have to be thinking about, it's no longer squares. Well, it is squares, but maybe you want to think about it to understand this better. You want to think about it as a rectangle block because it's the same color. So how many choices do I have to put red? After I've put in the black, after I've put in the green, how many choices do I have in terms of putting the red? And it's going to be one. It's one. It's not two because you have a double. The red is double. You know, it's like you got a double red, so you have to put there's only one double space in. There's only one space for the two of them. One way to get the two of them in, because if I put there's nothing such as like red and then some other red. They're both red, if that makes some sense. There's nothing like red 1 and red 2. Because we're just thinking about the color. We're not thinking about the specific we're thinking about the color, and there's only one way to put in the next color in the remaining 2 slots. So there's one way for the third color. On the basis of that, and on basis of what I talked about with this product rule, it means that the answer, the number of different ways I need to multiply. Those are all the choices I have. Which color am I going to use twice? Where can I put one of the first color? Where can I put the second color? Where can I put the third color? Okay, and it doesn't matter what you think about as the first, second, or third color. You'll find that you'll end up with the same answer. Actually, yeah, no, not quite. This is really tricky to explain, but I hope it makes some sense. You put in for the singles, you have the most options. So you put in the singles, and then you fit in the doubles, and you'll see how many different ways. Product rule accounting: 4 3s are 12, 12 3s are 36. So the answer to the question, how many different ways can you put in the 3 colors and 4 tiles when you're allowed to use a color twice? The answer is 36. Okay, hopefully that made sense. Counting, product rule accounting and methods accounting is a big idea, really super important idea, and hopefully this starts to give you a sense of it, and how we can use it